So now in principle, at some level, we know what we want, and so we just have to figure out how to say it. And that's what I'm going to trying to now. So the idea is a concept is a predicate on one and more arguments. And so here's a predicate sequence on the type T. And it returns a bool, true if T is a sequence, and yes?
Why parent?
Because I like them. It's a function.
But the functional part is in angle brackets.
Yeah.
So why doing it parents? It's a function on the C.
It's. I mean, you could do this. There's a few cases where that's actually a type.
Not for a concept.
Not for a concept, you're right.
So for a concept, it's never.
But for a perfectly ordinary constant expression as we have them today,
That's usually a type.
yes. Yes.
And you're not flexible.
No. Let's go little bit further and see where it goes without looking at the first one. Yeah. No, I mean, I agree. In some alternate universe, this would be the call brackets, and we wouldn't need this. But when I've looked at this a couple of times, there's just a lot of types that look like that.
Yes, but I mean, there are types.
Yeah, yes, you're right. But anyway, let's carry on there and see. So here we have. I think you like some of what we're seeing. But anyway, so we can have a template. It takes two type names, and the first one has to be a sequence. We have a requires clause here, and then we want the value type of the first one should be comparable with equality with the second one.
Wonderful. Except for the stupid parentheses.
Except for the stupid parentheses. Well, tough. Go and back in time and let Wirt convince me that you don't need. Let Wirt convince Dennis that we don't need parentheses after a function doesn't take arguments.
No, but here the sequence is a function. You're applying to S.
Yes. But by the way, they don't all have to be concepts. As a matter of fact, we use perfectly ordinary constant expression function. Yeah.
Let them look, but
Yes.
With the first argument to find, should it also be a construct?
What?
Should the first argument to find also be a construct?
yes, it should be.
Yes.
He was asleep. It was
Yes. No, it's just I find it hard to think about many things at the same time. And here it's mostly what are the right example, how do you express the fundamentals, and then I make typos. Okay, and basically the template uses you take something and you say find, and basically it goes down and says, okay, VS is a vector of strings. Is a vector of strings a sequence? Yeah, a sequence is basically something with a beginning and the end, so yeah.
Iterator of S. This is a type function. Again, at least what I call type function.
Yes.
Sort of, it's not a predicate.
No, it's a type. It's a type that comes out of find. So from my perspective, this is a function and it's being called. This is a type. Some types you can call. But
Will you show us how iterator of S is written?
I wasn't planning to.
Isn't it just an alias to...
Yeah, it's a type alias using template type name T using iterator. equals.
Whatever.
Yeah. It's no particular magic. You just write it in the current language. And as a matter of fact, for a very long time, we didn't have the concept keywords, and these were also perfectly ordinary functions in the language. They were just context-based functions. So, except for this keyword that requires, we could write everything in C++11, and we did. Sorry?
With enable if, essentially.
We started out with some enable if, and then the first compiled version simply did the requires, and that was all it did. It took a Boolean expression as an argument, and this was perfectly ordinary context-based functions, and there was nothing there. That, here, this just comes back. It happens to be using a type alias, but so very minimal magic for starters. Now there's a little bit of syntactic sugar to make it better, but only very little. So the logic is simple. VS is a vector of string. A vector of string meets this one. Jabberwocky, you can compare a C-style string with the value type of the sequence with the value type of vector of string, that's string, so you can compare them in your home. Okay, so, shorthand here, if you don't like the requires, we could write, we want a sequence S, and we want something that's equality comparable to S, and we'll call that one T.
One, and there is no comma.
There's a comma there.
No, but equality comparable.
Look, S, look at it. S is a sequence. T is a type that's equality comparable with the value type of S. Just a shorthand. It's a declaration. So some people like to say requires like that, and some people just want to say this is a sequence and this is something you can compare to the value type. By the way,
you could use predicate as a declaration.
yes. It just, I mean, what is a type?
You don't have a student brand.
No. A type, thank you, you can do without, I said you would like some of what I did. So basically, look at it. When we say double D in the square root, we say that D has to be something that, it requires that D is a double, right? But we don't say that, we say double D. And so instead of saying that we have a type name that requires it to be a sequence, we say it's a sequence. Shorthand. So if you're the compiler, we break it down to this and evaluate it. If you're not the compiler, I think this is better for humans.
I see, okay.
You're going to have a long discussion, especially with me and Andrew, because Andrew has been writing too many compilers, as I think, so he thinks this way and writes a lot of it like that, and I always shorten it to that. One of the exercises is take the Palo Alto TR from the office around here and rewrite it without using the word requires.
By the way, it is in the lecture directory.
Yes, we put it in there. But basically, I believe that exercise can be done. We can do everything that's in the Palo Alto TR, except for the semantic parts, which we're shying out of for a variety of reasons, and more. We actually have a container concept. I needed it for something. So we can do more of that, but we can do essentially all of that. The essentially comes from the axioms. And
Parses, Andrew's compiler parses.
oh yes,
This.
yes. And modular bugs, and modular thing, yeah, all of this, but yes. And we don't see any problems of checking definitions in isolation. That is, when we see the implementation of find, We can, in principle, look at the statement and saying, are we using something that is not guaranteed and give an error message? We are not doing this for two reasons. One, it's extra work, and there's some trickiness there. And two, we didn't want to put something in place that couldn't insert a debug statement, that we were afraid of getting too tight checking at this stage. So we think we can do this, but we're not going there just yet. That requires more work and more thinking. Given how we got caught with C++ OX concepts, we should be somewhat reluctant to barge ahead. And that's so you get the point of call checking, and a compiler can, as an extension, do fairly simple checking that the definition is all right, but we're not doing it, not requiring it.
If you have three types, not just C and value type of S, but value type of S1, S2, and S3.
We can write a predicate on three types.
Could you do it with this notation?
Yes, but I'll show you a better way. If you can introduce your types in order, you can do it. If there's a mutual dependency like this, you would require a requires, or some trickery I'm going to show you later. Okay, so error handling, simple and fast. So we have a sortable container. We make a container like that. That is, it'll sort anything that's sortable. And we have a vector, we have a list, we sort a vector, this is fine. Vector is sortable. Where vector is defined, it requires a random access. Fine and dandy. List, it'll get an error, and it will get, it should not work under the STL because sortable requires random access. And actually, the actual error message is list int does not satisfy constraint sortable. And if you flip the bit, the verbose error message a bit, you will get, I think, 4 lines more, which include the statement that says that you do not have a subscript operator or a plus. But
So it will not mention random access?
only, I don't think so.
Which would be, of course, the desirable thing. As an error message.
Yes, yes. But that would be the detail. I mean, what comes under this? The major point here is that this is a real error message. We can actually write that it will not do this because list events does not do what we said here. And you flip the detail one, I think it goes straight to operations as opposed to intermediate things. Sortable is defined as something that requires this and this and this. And random access, actually I don't know, but random access will look for plus and subscript. So whether it says both, that it could do random access because obviously it's down another predicate. And it knows what predicate it is evaluating. So whether it says you don't have a plus or it says you are not a random access because you don't have a plus. We just have to, this is one I've gone many rounds with Andrew about. Like all compiler writers, they want to spill everything. And I'm saying, no, the art here is to tell people what they mean, what they need, and not much more. So we have this switch. This is what you get if you're terse, and you get about 4 more lines with details. And I don't have my laptop, and if it is, it isn't even running on my laptop. It's running on my desktop, so I couldn't try it in real time. But download it and try, see what it is. Okay, this is much better than many pages.
Yes.
Yes.
So I assume the behavior here, if you don't satisfy the constraint, is it's just like any other template. It's just as if it's not an error. It just doesn't exist.
No. This is not SWIN-A. This is the call.
Okay, but you might have multiple.
I'll show you. That happens to be the next slide.
Oh, okay.
Nope, it's not the next slide. I'm sure it's 2 slides down, but it's beginning that discussion. It's beginning this discussion. Overloading is easy. So here we have a template find, still const missing, but anyway, it takes a sequence, and we have another find which takes an associative container. And so I have a vector of int, I have a multiset of int, and I say find, and it finds that v is a vector is a sequence, and so it calls this one. Here we have v s is a multiset is an associative container, and we pick that one. And this is just seeing that which sets of constraints are met. And so you can overload if it meets the sets of constraints from one and not the other. That's the story. If they are subsets of each other, then it'll take the one the biggest one it can. In other words, if you most specific, well, the one that meets the largest number of the predicates. So if you have something that can be called for a forward iterator and a random access iterator, and it has what it takes to be a random access iterator, it's harder to be a random access iterator. It meets more predicates, so it picks that one. It's simply a subset property.
What if they're disjoint or they're not?
Now this is okay. Here, they're disjoint. It'll meet either the one or that one or neither. Those are the alternatives. Okay, then you move them a bit closer, and here it meets them both, and they're not subsets of each other. It's ambiguous. If it's, yeah. And then finally, we have this case. If it meets both, it will take that one. That's the overload resolution rules for
So if
constants.
it's ambiguous, that's an error.
Yes. Yes. Okay, so we have that. So let's take the classical example here. Overloading is best for predicates. Predicates based on subsets of what set of these set of these Boolean expressions you meet. Easier than writing lots of tests. Yeah, this refers to the fact that people write overloads with enable if, and then they have to say what is true, and then they have to say what is not true, and when they add a new one to a set, they have to make sure that the true and not true is true for the whole set. It's a nightmare. So we don't do that. So here we have advance. We advance something with an input iterator. We advance something with a bidirectional iterator. We have something with a random iterator. And when I call it for something, we calculate what is true. I mean, if you are an input iterator, so you don't have minus minus, then you will call this. If you have minus minus but not, say, subscript, we'll call this. And if you have the subscript, we'll go with that. Of course, that operator is a sort of a stand-in for the whole set of operations necessary for the requires. You can just look at the definition of it. So it picks the highest one it can. The point is, nowhere do you say there is a relationship between those types. That's computed. So the whole debate that was towards the end of the killing, before the killing of C++ OX, was how do you specify class hierarchies and handling ambiguities and such. There aren't any classes. This is the resolution mechanism, and we just compute it. We break down these predicates into their Boolean components.
So tags are gone.
What?
Tags, type tags are no longer used.
Nope, gone. It all becomes a long Boolean expression, and then you calculate which are subsets of each other. If they're subsets, we have this one. If they're not subsets, we're up here. And the paper describes that in a couple of pages in excruciating detail, beyond what is necessary for a standard. It's just how to do it. Okay, so the question is, how do you write constraints? Basically, any Boolean expression, I should be more precise. Any Boolean expression, no. I don't know if you have restrictions of putting Boolean expressions in that doesn't depend on the arguments. But anyway, you can write a Boolean expression, and that's basically, you can use type traits, you can use const expr functions, you can use the simple Boolean operators and or not. Just standard Boolean stuff. And to help you, there is a help function called requires that you give an expression, and it'll return true if you can compile expression, and false if you cannot. This was a helper function that was built into the compiler to do some dirty tricks and trickery, and it turned out that everybody loved it. And if you don't, you have to have a few pages of type functions in a library where you have to read the header and then go through. So making it intrinsic runs faster, is better defined, and it allows you to write a near arbitrary set of tests on valid expressions. Again, the specification isn't detailed in the document, and you can go and try it on the compiler. And we want, for some reasons I'll show you in the next couple of slides, want to recognize a concept syntactically. Nothing I have said so far, really nothing, requires us to know what a concept is. It can be done with constant expressions. But it works much better if we know what a concept is. It also gives us a handle eventually to hang semantics on. So we just replace const expr with concept. And now we know it's a concept, and there's some things we can do syntactically, basically, that would be hard to do without it. And now I'm just going to do a detour into lambdas. So we now have, by here, a fairly coherent set of checking of templates. But people are writing a lot of lambdas. And people will get generic lambdas, that is lambdas where you don't specify the type. And so there'll be, I fear, a whole untyped, unconstrained subculture writing write-only lambdas with write-only types. And we have to think about how to deal with this. And people by and large don't believe me, there's no problem, everything's fine. I don't think so, but let's see. Lambdas are very closely related to templates. You can think of them as a generic lambda as a template, just like you can think of a lambda as a class. Okay, so the checking when it comes down is really quite simple. If you have an unconstrained lambda, known as generic lambdas, and an unconstrained template argument, you're basically back in the world we know. You have to wait and see how the lambda is being used by the template. You have to wait for the instantiation, you have to check the instantiation, and you get the error messages you deserve. And this is the way a lot of people think, and they are used to the old templates, so They think they're fine. I don't think it's fine. If you have an unconstrained lambda and a constrained template argument, like you have a find if written in the way of that find, it wants a predicate, you give it a lambda, you check whether the lambda is a predicate at the call point. No problem. So we use that. This has not been implemented yet. People are seriously thinking of implementing it. So if you have a constrained lambda and an unconstrained template arguments, then the call to the lambda will be checked at the call points, and we get some benefits there. And if you have a constrained lambda and a constrained template argument, we just add the two sets of predicates, and we get the best checking. Now, I think this makes sense and is actually necessary. That is, if we have lambdas that are really a kind of templates, and we have constraint templates, and we need constraint lambdas. It doesn't make sense without it. Some people say, it's fine, we don't like type checking anyway, but I very strongly disagree. So, but anyway, if we have this world, this is what we need. So we have to figure out how we deal with it. One of the problems with one of the things that attract people to lambdas is they are very terse. You can just drop them in, write them without thinking too much about it, and you don't have to write too much code. This is it worries me when you have an operation and you don't even name it, and if you have an operation that's so terse that you don't have room for a comment, I worry about that. But then I want to make sure at least that you can provide the constraints. Like if I have a lambda that requires a predicate, I want to be able to say that lambda takes a predicate, not just an arbitrary type. And so I have to work on a notation that's really, really terse, because it has to fit into the design space of the lambdas, where people are complaining about every piece of...
Implemented?
Yes.
The terse notation?
I have not tried it because I have not been there for the last month.
In any case, that would be fabulous.
We have definitely
I will
agreed.
give you even parentheses.
We yay!
This is nice.
I discussed it with Andrew when I was back in, and Gabby when I was back in College Station about 4 weeks ago, and this was on the list of things to be done next, and I have not had a chance to check it. So I think it is implemented.
Just let me just interject one sentence. Guys, what it means is that you don't have to write all this template crap. I mean,
Yeah.
this is really very nice.
But that means concepts are suddenly in the type namespace.
No, they're in the concept namespace. This is why I need the concept keyword so I can recognize them syntactically. So when this is a concept, I know it means this.
It's a shorthand, but it's beautiful.
It's a shorthand, and this I know means that. So my conjecture here is that as a human, I like this stuff. And as a compiler, I like this stuff. And so we just break it down.
You're addressing humans here.
Yes, mostly. You're never sure when you have compiler writers in the room. I used to write compilers for a living, so I can say that kind of stuff.
I think what he was saying was that container now, you can't say that I have a type called container because it's a concept.
No.
So therefore the same
Yes.
namespace. Types and concepts can't have one,
Which
or
is
is there? Or
Actually, you
problem in C++.
yes, you probably can.
Think about
Just-
it. We have already common namespace for functions and classes.
Yeah.
That's something he had to do long time
Yeah.
ago.
And,
So now he just makes virtue out of necessity and say, I'll continue.
Yeah,
There is a common
exactly.
namespace.
But anyway,
Very
the point is that you can't use that name. That is an implementation detail. That's why it starts with a double underscore. So then you don't have to. If we get to the end, we can go into some of the details of this stuff, but I believe it works. And basically now we are to the point here where we can say sort a container and give it a vector. That's all you have to say. In other words, we are at this slide that we were before. Doubles are just things that are doubles, and containers are just things that are containers. I don't have to screw my head off and put another one on when I'm going from the one world to the other. Okay, now.
Is there a way of getting rid of containers and class definitions? Templates and class definitions?
No. There's never any way of getting away with things.
What if I stick a concept, if I say struct container X, wouldn't it automatically make it a template? If you see what I'm saying?
Yes, see what you're making. We actually, I'm not sure if this is implemented, but I think it is. Look at this one. Auto x equals 7.
I do not.
Container is a concept. Now X will accept anything that is a container. Actually, no, we don't want vector of int here. What we actually want is VS.
Specific vector.
Yeah.
No, but why wouldn't it work with struct definitions? If you, in a field name, use a concept, that automatically makes it a template struct.
If I start with a member.
Oh yeah. Yes, I think that, yes.
Yes?
Yeah, yeah. Okay, void. Sort.
No, I'm talking struct.
Oh,
I'm talking struct.
yeah, struct here.
If you say struct X, open brace, container something.
I don't know. We are not doing it from a member of a struct and then deducing that the whole.
Because then you could get rid of word template once and for all.
But how would you concretize that particular struct then if you really needed to specify the
Oh, you
type?
do, you with angle brackets.
You initialize it, but
You need angle brackets to say that this, whatever the name of the struct was, say foo. We say foo of vector of int or whatever.
What if there's multiple?
So you use comma.
Alex, I'm pretty sure there are dragons here, and we're trying to move
But getting rid
gently.
of templates is such a wonderful
It's very hard though.
I'm almost there.
You're almost there. Look, we're making progress.
Just
C++ 23?
yeah, it's 23.
I don't think we are going to make it for 17, so that's. But it's possible. But
You have to mention things. I have been mentioning things for many years.
yes,
And lo and behold, some of them.
eventually some of them happen. Some, yeah. Anyway,
Interesting.
yeah. Anyway, so back to our headache-inducing examples. Specifying merge, one of Alex's favorites.
They're working on it right now. This class is doing merge.
Yeah, this is. I mean, I was picking, in the best tradition of this, the simplest things I could find, which are things like find and sort, as long as you don't look at the algorithm. Now let's go for the headaches. And I'll do merge, and if you think that's too simple, try accumulate. And basically, here is the specification of merge. It takes a type name for, another type name for, to, and the type name out. And then we have to say that the first one has to be a forward iterator, the second one has to be a forward iterator, not necessarily the same forward iterator. We have to have an output iterator, and we have something assignable here, the value types of something or other. If I've got a bug, tell me later. Anyway, but basically go down, you list all of this. And that's the way you can specify merge. I believe this is copied straight from the Palo Alto TR, but then I'm well known not to be able to copy a simple set. But this is the way you say it. And there are how many merges in the?
Two.
That's two, just two. Anyway, the functions tend to come in clusters. And so this is not some.
Set union, set intersection,
Yeah,
set
that's the
difference.
other example.
All of these guys have identical.
Exactly. So I think we have to write this 6 times to write the.
More than 6, it might be 12 times.
Okay.
Some huge
So I'm
number
off by a
there.
factor of 2. But anyway, you will soon realize that sort of the cute little examples here doesn't generalize to handle everything. And if people have to write this, they're going to get it wrong. Repetition in serious
That's
things.
library
There's
writers write.
something.
But
There's
you remove at least 3 of those lines, right? By placing
come
type
in.
name
Next
before.
slide. Next slide. I'm explaining why I'm working on the syntax. You can already say everything. There are people who think that this requires stuff, covers everything you possibly need, and the rest is complexity and confusion. So I'm arguing that, yes, we have made major progress, but we're not there.
We're
So they
waiting
come in
for-
clusters. They come in clusters. There's mergeable and there's sortable and things like that. Sorry, I'm not used to.
Are you going to show us the solution? Yes.
Yes. Usually I speak to people that are less versed in this, so maybe I take too long. But anyway, yes, of course you say we want a forward iterator, an output iterator, and here comes a function of 3 types called mergeable. It's just a type function of 3 types. No problem. And I couldn't help thinking of this cartoon here.
But couldn't you make one more jump?
Yes, I can make some more jump.
Yes. This is.
The curlies here say, give me 3 types that meets the criteria of mergeable. So we simply want to say, I want 3 types that are mergeable, and I use them like that. So basically, concept name, identifier list, introduces constraint names mentioned there. There's a wild discussion just now whether you should say template, sharp, mergeable, end sharp there, and I'm against it, and we'll see where it goes. I think template is completely redundant in this context. Yes, it is, but if people think it's not redundant, they always ask, I don't know if you know, when a new feature comes, first it is useless, incomprehensible, and slow, and can't be implemented properly. And next, they then want really heavy syntax so that people can see there's something new and dangerous coming. And then you wait a couple of years and everybody curses the heavy syntax. Okay, this is what you can do. This works too. And there, by the way, is mergeable. It's a template of 3 argument, concept bool, mergeable, and it writes all the crap here. And you could make the syntax for concepts different from the syntax from.
You could say that now? Type name. You don't have to say type name 3 times?
No, that's a bug. Sorry, it's a bug.
You
have to say-
Nice if you can.
I know. There's also, if you invent, just a second, if you invent a syntax, you can simplify this, but
Did you hear what?
no.
Why don't you introduce a keyword type names?
Yes.
Actually, I believe it's not a bug, because I listened to this talk by the Google guy, who I always forget his name, and I'm really sorry for that, but he uses that same syntax with like sequence, and he just lists this.
Dr. Gregor, and he,
No.
no, that's probably ... or something like that, no? Well, if it works, I didn't know it, and
Would be nice.
maybe.
Well,
Yeah,
it's
we'll have to
again,
look it
all
up.
of that, nobody will ever see it in the sense. People will see the previous slide.
Preview. This is what I want people to write. And this is for when you're finding a new useful concept. But the novelty here is that the concept introduces and specifies the whole thing, and we can then hide the whole mechanism behind, introduce the name that meets the predicate. And once we get semantics, that predicate will have deeper
But this
meaning.
will not change.
No.
Even after semantics is
That's right. It's been hidden. This will change.
Well, something will be added.
Yeah. Also, so
And you can overload these guys.
oh yes,
Because then you need two kind of mergeable. The
Yes.
one which is used total ordering and the one which takes.
yes. So, what I actually imagine, we actually discussed this, but I think we'll have mergeable, and whether we'll have the other one, the total order, or whether you'll simply write mergeable and total order. Mergeable requires total order, something
No,
like
but
that.
the signatures are different.
They are?
Go to the previous. You see, you either explicitly pass the predicate or not.
Ah, I see. Okay.
They're different.
Okay.
So depending on that you record, you know.
Yeah. But I get lost in these things.
I get lost.
yeah. I mean, if your syntax and semantics is fixed, you can concentrate on the use of it in the algorithms. When they're not fixed and you go forward and backwards, you end up getting confused. Okay. So I'll just make a little rant. I've never liked the word paradigm. I think Kuhn got it wrong, for starters, and the people who picked it up to give object-oriented programming a unique status and imply that it superseded all previous forms of programming just got it wrong. And so, and people who have been trying to do that with generic programming, I think, also got it wrong. It's just programming. And so, what we have here is that a lot of the distinctions between conventional programming and generic programming and object-oriented programming, I think, are an illusion. People look too much about the language features. Do you write x.f of x, f of nothing, or do you write f of x? That's superficial. And it comes from an incomplete synthesis of techniques for using it. I mean, most people say that the sort of a container is radically different from the square root of a double. I would love to really be 100% certain this was untrue, but I'm trying. And I think the distinction does harm. It limits us for programmers, it forces workarounds, it leaves powerful techniques out of use when people want to be purist in one way or other. And here's a little example here. This is a classical example of an object-oriented program. You want to draw a container of shapes. In the old days, it was always a list of shapes or something, but we've generalized it's a container. So I want to say draw all containers, and I use for each, so the container, and I call this. I didn't bother putting the requires of the container should be requires of shapes because I'm saying it there. That delays the checking. If I want to move the checking up, I put it here with the requires. But the point is, I don't think anybody with a straight...
Why did you say container angle bracket shape angle bracket?
I might be able to do that depending on how container was defined. It has not been defined that way by... The concept container has not been defined like that. I would have to say it requires value type or container.
So you couldn't pass.
Yeah, but I can definitely put specification up here, but that's not my point. My point is that this is about the shortest expression of a very general version of the classical example. It is clearly object-oriented. I am drawing a set of shapes out of a polymorphic hierarchy. It is equally obviously a generic program. I mean, this is a generic function, right? It takes a concept argument, therefore it's implicitly a template. Also, it uses a well-known algorithm. This is one of the simplest ones for each. So it's clearly generic programming. And you know, I mean, that's just looks like an ordinary function, so it's not that different from what we learned in kindergarten or thereabouts. So I think this one crosses all these distinctions, and we should be a little bit careful not to be purists in one of them. So, and modulo that possible requires clause here, this is actually the nicest solution I know to this particular problem.
It would be nice to say container of shapes. Sound good.
Well, let's get the terse syntax accepted first. I'm sure there's a way of writing this, but I just haven't worked it through. And there's the reading. You have some of them downloaded already. The concept lights document, we downloaded the next version beyond this. That just came out a couple of months ago as opposed to this one, which was in March. And that one there is the Palo Alto TR, which is at the root of a lot of it. And this is just a paper that Andrew and I wrote for a conference. It contains a lot of the ranting about what concepts are and why they are not the way you used to know them 5 years ago, and how many of them can you live with, and things like that.
So one question I had was, the constraints are on the caller. You're not constraining the implementation
Nope.
of the old concepts.
That's right. And that makes some people very angry. And as I said, I'm just want to be very slow moving in that direction. You can do an awful lot of checking with the information given. It's just not required to be done. And one thing I worry about is what you've seen in some of the functional languages, especially Haskell, is you can't even put a debug statement in. That is, if you make any change for debugging, tracing, call logs or whatever, if you do any of that under a sort of a closed system, you have to change the interface.
It's no longer a function.
No. And there's people who say, that's good. Let's stop people from doing all of these nasty things. But I do debug my stuff. I do want traces sometimes, and sometimes for very good reason. Even in the final ones, I want to do logging. But do I have to change my interface all the time because I put something in the function that are not there to perform its function, but to do something related? Till I have a really good answer to that, I am a bit reluctant to tighten the screws even further. As it is, the information is there. Let's see, right? The information is there to do an awful lot of checking on a function. If I say it has to be mergeable, I can start looking at things and see what is being used if I'm a compiler. and let people use a bit of heuristic and initiative first before we start tightening the screws. And I'm not sure we know what we're doing if we do that.
And this is, again, many years of experience I needed to fully grasp.
Yeah, I think I had a statement saying we have to be careful here. We don't understand it fully, something like that. But that's definitely my opinion, is that it's too soon, and we are getting a huge amount, more than 90% of the benefits of concepts comes here. Let's say there's 100 users for each implementer. We get a
Why
99.
not
And
putting semantics? It's so easy if you don't do anything with it.
It would cost me many days to defend this, and it would be a focal point for the attacking to throw it all out in the standards committee. It
But
will
it's
be
just a
hours
stylized
and hours.
comment.
But you see, I'm not arguing for what it is. I'm arguing for what I know will happen because I've seen it happen. This is just difficult to get through. Let them get this.
I want to report did contain.
Yes, I know. But people, there are people, including some compiler writers, that are very vocally against any form of semantics in the specification.
Just skip it. It's not, they don't need to.
They don't want redundant things into skipping, and then they'll claim that their customers will require them to use them somewhere. And anyway, if the semantics are not used for optimizations that they need, they shouldn't be there because it distracts people. Look, it's bogus, but it's real concerns to somebody, and they haven't grasped it. There's people who want to prove the axioms. If there's an axiom, you must prove it, right? I mean, that shows something about their math background, but it is a very, very common thing that you see an axiom that requires total order, and they say, but I can't prove a total order. And I said, you're not supposed to. I said it was an axiom. It means you can use it. But what if it's not true? You can have an endless discussion about singular values.
Yes.
I'm telling you, I can't do it just now. You can get this.
You cannot name names.
Of course I could, but of course I wouldn't.
I thought they all did.
Well, we haven't been doing it that long.
I've been doing it. I mean, the discussion goes back to 90s.
Yes, I know.
Should equality satisfy some?
You know, one of the things that I had to consider very early on with C++ was this assumption that most languages were designed for future languages, future problems, and future programmers. And it was assumed we would have better computers. Yep, that's right. That we would have all the simple problems solved, so we could concentrate on something much more esoteric and not handle the details, and that the programmers would be smarter and better educated than what we have today. The latter two I didn't believe. I sort of caught on to that one very early on. There's a lot of grubby problems still, and you know, some of the programmers are us, and we didn't get any smarter. We may have gotten more experienced. And I don't see the evidence that the schools produce, on average, dramatically better programmers than what we saw 20 years ago. So we still have the old fights to fight, and well, I decided to fight this one and not the axiom fight. It's simply pragmatics. If it was, I forced axioms, successfully forced axioms into the C++ OX design. And that was not one of the things that caused it. It was not one of the things that was a real burden to anybody. But it was part of the things people disliked and part of the reason for the opposition. I didn't want to do that again. People will learn this. but not in the next year.
22nd century.
I don't know. It's not inconceivable, though unlikely, that we would get axioms in C++17. My guess is that it'll go one more cycle. But pure pragmatics here.
So requires uses an AND Boolean operator.
Yes.
Does that mean I can use ORs and NOTs in there?
Yes.
Is that not dangerous?
You can use OR. I'm not sure if NOT is allowed. We had some long discussion about the meaning of NOT, but OR is definitely there. No, it's just Boolean algebra. We just calculate the things and see what the value is. Now, it is true that when you have an OR, you have two alternatives, and if you have ORs nested within ORs, nested within ORs, you get lots of alternatives. But this is one of these people, when you talk about OR, starts talking about what's the phrase? Exponential complexity. Doesn't worry me too much with n is 1 or 2. And if you don't do that, what do? You break the predicates down into something that doesn't have an OR. This has this one, this has this one, and you have an overload. And the OR is there anyway. Similarly, if you don't have NOT, you simply put it inside a const expr function. You got something that is true only if something is not true. So you can do it. But as a notation, it's not in there. But we have AND and OR.
But let me, however, add, while you can do it, you shouldn't. These are not things which are natural. For example, I don't know whether Paul remembers, we never use not.
I think we came up, no, we never used not.
Use not, and we have one example of or.
Yeah.
So
We don't actually support not. And I'm pretty sure we have more than one example of OR.
So these are seldom needed.
Yeah.
So concepts are extensible, correct? I can create my own concept?
Of course. It's just a Boolean function. So you just use it as a predicate inside your function, as part of the predicate you do.
While you can, whether you should is another story.
Yeah, that is another story, but the point is there is no language mechanism for extension. There's no refinement operator or anything like that. There is the fact that you can write yourself a Boolean function, and you could use any existing Boolean function as part of your calculating your value.
So nothing prevents us from shipping a library with 120 concepts. That would be-
Oh, and people
that would be
will.
a-
And people will. People will. We can't stop them.
Yeah.
But and so the first part of my talk is going to be very important when this goes more public, and most people will ignore it. They don't care about all of this fancy stuff about thinking about programs. If you can write it, you must write it, and so you do all kinds of horrible things. Shows you're clever.
All right.